All right, let's do a triangle congruence proof example. I'm going to do this proof two ways, once in the more traditional two-column proof way, and another using a flowchart, which is a little more, newer textbooks are using that. So if you're a person that your school is using a book or a program that uses flowcharts, you could go to the next chapter in this video and see the problem work that way. All right, we are being given that AB and DE are parallel. I'm going to mark that in, that these two are parallel to one another. And that AE bisects DB. So that means it cuts it in half like that. Now, I'm going to just extend these parallel lines a little bit like this, because I want to talk about, and then I'm going to also extend these transversals, we call those, like that. Because we know from our work with parallel lines that these two angles are equal because they are alternate interior, and so are these ones. Now, we also know these because they're vertical angles. Unfortunately, there is no angle, even though we can establish that they have three pairs of angles. We did need one side. So I'm going to aim for angle side right here, where the side is not included in between the angles. Okay, so let's begin with our two-column proof with stating what we were given. We were given that AB, not congruent, but parallel to DE. That was given. Now let's reason with that then. We then know that angle CDE is congruent to CBA because they are alternate interior angles and they are equal. And we could say that. You could say are equal. Okay. We also then know that CED and CAB are congruent because those are also alternate interior angles. If you would rather have used the vertical angle one for one of these, you certainly could have. It wouldn't have changed much. Okay. AE, let's go back to our other given, bisects DB. This was given. Now, what did that give us? Well, it gave us the fact that CD was congruent to CB. And that is the definition of a bisector. Cut it in half. So here we are. We have established here that we have angles and we have this side. So the two triangles are congruent. By angle, side. So always make sure you list your givens, but then also say, well, what did that tell me? If this video helped you, please like and subscribe for more geometry content. All right, so using a flow chart, let's start marking in what we were given. AB and DE are parallel, so I'm just going to mark in those parallels. And AE bisects DB, so bisects means it cuts it in half. Now, it feels like we don't have enough, but I'm going to just extend these. I think sometimes it helps to look at parallel lines if you kind of extend the lines, okay? Like that. Now, when we have parallel lines cut by a transversal, we create angle relationships. Those two are equal because they're alternate interior. These two are also equal because they're alternate interior. So we have two angles. We actually have three angles because, of course, these are also equal. They're vertical. But we have two angles and a side not included. We're going to be able to use that. Now, our flow chart here is going to get a little bit, it's going to have a few steps to it, because we always, of course, start by saying, well, AB parallel to DE, because that was given. And the fact that we were given that actually gives us a couple of angle relationships. So I'm going to do this. First of all, it established that angle CED was congruent to CAB because alternate interior angles are equal. Okay? Let me do this like that. And then maybe I'll just move this one over a little bit. And we also knew that angle CDE was congruent to CBA, same thing. Alternate interior angles are equal. And again, both of those things we got because of the parallel relationship. Okay. Next thing we were given was that AE bisected DB. That was given. And what that gave us then was that CD was congruent to CB. And again, this is the definition of a bisector. So this gave us our angle side. So these all flow together to say that these two triangles are indeed congruent by angle side. So always make sure you list your givens and then kind of let those flow. Okay, now that I know that that was given, what does that give me? If this video helped, please like and subscribe for more geometry content.